Boas tardes a todos. Bem-vindos. Welcome, everybody. Thank you for coming here. Thank you for joining our room. I just told a few minutes ago that there are some people from Portugal, maybe even born in Lisbon, that have never seen this room. This is really a problem, but we'll try to solve it. Well, we will have a very busy and interesting afternoon. And since I have the privilege of having been born in the Azores, I'm particularly interested in this subject, not only because I also work in telecoms and have worked long ago in the earliest cables, the time where the attenuation and fiber optic is layered effect. That is 60 years ago. So like it's the case. So I'm very interested, but even more in this case, because besides connectivity, which is very important, island, very important, also because what you can do with it, besides communication. And that is something that interests me. This is a particularly new thing. As far as I know, it was almost discovered by chance. Nobody ever thought that this would be, something very interesting. But I'm sure today we'll learn more about. Certainly, I will learn more about possibilities of using submarine cables that are probably more cables from here crossing the Atlantic than fish doing the same thing. There are so many. I keep losing all the new cables that come in a few years. And so I will just stop now and give the floor for a short while from the table.
Thank you.
The floor is yours.
Maybe I speak from here, if it is okay. So, hello everyone, good afternoon. So first of all, welcome to this meeting. So this is an initiative which is part of several events that we've been organizing in Portugal, connected with themes which are key to the decade of ocean science for sustainable development. And we have always done this partnership with the Academy of Sciences, with the Ministry of and the idea in this case is to look for new ways of how we can observe the ocean, how we can protect the populations onshore with new tools. And one of the opportunities that is arising now is the possibility to instrument submarine cables. And so what we call now the smart cables. We have here with us Bruce Howe, who is the specialist in this topic. And I'm sure we will learn a lot about this. And since we are going to replace the cam ring, which is linking mainland Portugal with the Azores and Madeira, this is a wonderful opportunity to see whether we can instrument this cable. And this will help us to constrain the location of earthquakes, to have better early warning systems. And so this is, and also at the same time to monitor the sea. So that's why we also invited people from the goose community and people interested in ocean observation, because this could be also a possibility to instrument these repeaters with different type of sensors that could measure different types of variables like temperature, salinity, and so on, pressure, and so on. Thank you very much.
We would like to ask Dr. João Cadet Matos, who's the President of the Board of Directors of ANACOM, to give a word. Thank you.
So, good afternoon, boa tarde a todos. It's a great pleasure to participate in this opening session of this relevant meeting dedicated to the smart cables in a sea of connectivity, serving science and populations. As it was already mentioned, we could not find in Portugal or in Lisbon a better place organize this meeting, given that one of the purposes of this initiative called Smart Cables is to provide a better research in all the domains related with the development of this connectivity between the different continents. And so, thank you for the invitation to be here in Academia das Ciências de Lisboa. It's also a privilege to have here in this opening session the main partners of this endeavor. ANACOM had perhaps the privilege to be the first entity calling the attention for this opportunity that would be to replace not only submarine cables by new submarine cables, but to replace and to provide submarine cables that are smart. And so the first time that I had the opportunity to discuss this matter with Mr. José Barros, that you suppose you all know, and that is always behind the scene, but organizing all these initiatives that ANACOM was organizing during these years. It was with him that I had the opportunity to discuss this possibility. Indeed, there is another place or two another places where it would be completely justified to organize this meeting, and these places, one was already mentioned by Mr. Carlos Salema, and is not a place, is 9 places, are the 9 islands of Azores. Because, and yet the second place is the 2 main islands of Madeira. So it's given the fact that Portugal is composed also of these 11 islands, Azores and Madeira, that allow Portugal to be one of the largest countries in the world. Sometimes in Portugal we used to remember this fact because some Portuguese consider to be a small country, but indeed when we consider all these sea dimension, we realize that Portugal is in fact one of the largest countries in the world. And we realize that given Azores and Madeira, so that's the reason why I'm mentioning the relevance of these islands, given the relevance of these islands, we have a good opportunity to use the submarine cables, not only to improve the telecommunications dimension. That was the first reason to have the submarine cables crossing the oceans. Today, of course, to help the digital development of the regions connected by these submarine cables, but we realize that there are new dimensions. And during the conference today, we will have the opportunity to know more about these opportunities. And it was very easy for me when I had these discussions, these first discussions already 5 years ago. It was already a long journey to see that first Portugal is obliged to prepare the replacement of the submarine cables connecting the mainland with Azores and Madeira, and we are obliged to do that because the current submarine cables are concluding their life time, so we are obliged to replace these submarine cables in order to avoid a problem of connectivity between all the regions of Portugal. But we look forward and we understand this opportunity to have these dimensions that we call smart cables. One important dimension, and that we are always afraid here in Lisbon, is about earthquakes. Fortunately, the largest earthquake took place a long time ago, but each time we are going ahead in our lives, we are afraid that again we can have this type of experience that destroyed, as we know, in 1755, a large area of the city of Lisbon. For the foreign people that are participating in session, I invite you to visit the museum where you can listen more about the history of this earthquake in the main square, Terreiro do Paço, or Praça do Comércio, near the river, where you can learn more about this impact, the devastation that we had during this earthquake. So, if we can do something to not to avoid to have again an earthquake, but to have some alerts, some information that can be used, this is really of all the national interest. And so, since the beginning, looking for this dimension of smart cables, ANACOM understood that is our obligation to provide submarine cables with this kind of solutions. Of course, this is a new area of research. This implies investment, but mainly implies this combination of work between our scientific system, so universities that are collaborating in this project, different universities in Portugal, not only from mainland but also the University of Azores that is collaborating in this project. Of course, it was completely obligatory to have the support of the Portuguese government, and so we are very grateful to the Portuguese government because it was already decided to have smart submarine cables. So this is a decision, and we are very happy to see this decision now being concretized. And the other relevant dimension was linked to the research in the aspects related with oceans, the dimension related with the climate change, the oceanographic developments and preservation and environment aspects. So all that can benefit from the submarine cables if we are clever enough to introduce these smart dimensions in the connection. So today we will learn more about this work. We are very grateful to the different colleagues that I can tell that are really good friends of Portugal in this project, namely Mr. Bruce Owen, that will be the first speaker in this meeting, and that is helping us a lot in this project. So what I'd like to say to conclude is that tomorrow I will be participating in an important event, not in Azores, but in Madeira, and I know that we are all in Portugal waiting for the concretization of this project. Unfortunately, it was included in the budget for the current year. Unfortunately, we are now end of March and we had not yet the approval of the budget for this year. We have to wait for the results of the elections. We had a second count to complete the procedure, but at least last week we had the announcement that this week we will have a new government. At least we will have the appointment of the members of the new government by the Prime Minister. And as soon as possible, I'm confident the Parliament will approve the budget and I'm confident that in this budget we will have this project with high priority, and that the company, the public company that is already in charge to concretize this new connection between the mainland Azores and Madeira, that is the Portuguese company, public company IP Telecom, that will be responsible for this project, will start all the implementation of the project, not the following months, but as soon as possible, because according with the timetable, we should have this new ring, this new connection, mainland Azores Madeira and Madeira to the mainland, concretized before the end of 2024. So it means that we have already now less than 3 years. It's a very demanding objective, but perhaps with the help of everyone, it will be possible to concretize this project in this timetable. Finally, my last remark to say, and that's also a reason to be in this place, submarine cables, and Portugal started submarine cables already 150 years ago, so it's a long history. We had also a long history of connection the different continents. So Portugal was the first country to have these submarine cables connecting all the continents. And so we are now considered to be in the right place, also to benefit not only from the submarine cables, but from all the new outcomes that can be connected with submarine cables. And today we will listen about the relevance of data centers, and also about the opportunity that will be Madeira and Azores, namely Azores, that is exactly in the middle of the Atlantic Ocean between Europe and North America. So thank you all. Thank you for the other organizations that with ANACOM are organizing this meeting, and I wish you all a good work. Thank you very much.
If we could ask, thank you. If we could ask Professor Miguel Miranda, President of the Board of Directors of IPMA.
It's not so easy for a professor to speak seated, you know. This is normally for politicians or for ministers, but I am much more used to be on. We are having today a seismic swarm in the Azores, in the islands of São Jorge, that started 2 days ago, more or less, where we have earthquakes and, of course, volcanic activity, not so far from the surface, and we must deal with this reality. Portugal is a country that lies on a very dynamic area of the planet. We must understand this, but to be able to monitor and to adapt ourselves to this dynamic Earth, we need new approaches, and we need the capacity to be able to have monitoring devices that can survive even a big crisis. This meaning a big earthquake or a big tsunami or even a big volcano in the Azores area. We must have this kind of tools. In most areas of our activity, frankly, we are very old guys. Imagine, for example, draft. We are having a big draft in Portugal for, I would say, 1.5 years now. And when you see the solutions we have for draft, they are not so different from the solutions that the Romans used to develop 2,000 years ago. We are not able to do nothing more intelligent or smart than to do aqueducts, or I will say proxies of aqueducts. Fortunately, in this area, we are able to find new solutions for old problems. And my view is always the same. Past solutions cannot solve our today's problems. Past solutions were able, in some cases, to solve the past problems, but not the problems we are having today. Our needs are the same. We need to be safe. We need to eat. We need to be healthy. But while our needs are the same, our life conditions are very, very different. And this approach that gains from the developments in IT technology and IT research should be mostly welcome. Finally, we are in a war. We had a big tsunami, we had a big earthquake in Japan, we had a big pandemic, and we have a war. Our generation, I think, has the whole stuff. And when we see the war that is going on in our televisions, hopefully, we understand that the Atlantic is our domain. All the stable alliances, all the stable ways of seeing the world, seeing life, are homogeneous across the Atlantic, and only across the Atlantic. This is why the new portal that IPMA is going to develop is called We Are Atlantic. And this project, the Smart Cables project, will be a part of the backbone of our Atlantic future and of our Atlantic life. Thank you for inviting me to be here.
Can I invite Dr. Raquel Ribeira to speak as a representative of the Ministry of the Sea?
Good afternoon. If I'm allowed, I will stay seated because I have a message to pass on to you. Due to the impossibility of attending this session today, given his prior obligations to a meeting in Monaco, the Minister of the Sea of Portugal, Ricardo Serrão Santos, indeed wished to meet you today to address the vast possibilities of smart cables in the ocean, but has sent a message that I will now will pass on to you. Dear colleagues from the table, dear fellows of this academy, dear conveners, dear partners and colleagues. The Minister was very pleased to associate the Ministry of the Sea to this event, co-organized by ANACOM, the Lisbon Academy of Science, the Portuguese Committee for the IOC, and the Portuguese Institute for the Sea and the Atmosphere. These walls, wonderful, beautiful walls, witness more than 240 years of advancement of sciences and education. Today we discuss the advancement that can be done to obtain real-time data from the ocean through submarine cables, responsible indeed for the vast majority of intercontinental communications in the era of internet. This advancement is truly needed. In fact, ocean digitalization lags well behind land. Portuguese institutions are working together to fill that gap. This is not a new thought or plan. Since 2012, 3 UN agencies, the International Telecommunication Union, the IOC, and the World Maritime Organization, have come together to address the possibility of smart cables. But these same agencies have put together a decade action or an action in the framework of the United Nations Decades of Ocean Science for Sustainable Development on using smart cables for climate monitoring and disaster risk reduction. And this is particularly relevant for Portugal as a coastal state where one of the first tsunamis registered in historical records took place just 24 years before this academy was created, so not so far ago. And two, where the impacts of climate change can be quite significant, namely through drought phenomena. Moreover, smart cables add to the range of equipments and infrastructures that build up this era of big data, taking the best profit from the 5G generation, getting more and more real-time data. Moving towards a digital twin of the ocean opens tremendous possibilities. For instance, a very dynamic and adaptive marine spatial planning across the seas of different nations, or the possibility to better perceive the impact of multiple stressors on the ocean with multiple origins. How extraordinary it is that only in the last 50 years, technology has advanced to the point that we can examine the ocean in a systematic, scientific, non-invasive way and near real time. As you are aware, the third Portuguese ocean strategy was approved in 2021, last year, and recognizes the need of exploring opportunities linked to the establishment of mooring points for underwater cables, including the installation of interconnection hubs and data centers, with the possibility of collecting environmental and seismic information, digitizing the ocean, and improving communication facilities within the national territory, continent, and islands, increasing wealth and job creation. And therefore, the strategy's action plan integrates targets concerning the digital ocean, including one regarding electronic communications ring via submarine cables between the mainland, Azores, and Madeira, a matter I believe will be addressed this afternoon. Underwater cables and smart cables are not only an important component for communications, they may become the perfect asset to accelerate acquisition of ocean data, improve ocean forecasting, and help economy. In that sense, last month, Portugal was signatory with a few other countries of the intent to transform Mercator Ocean on an intergovernmental organization to coordinate and accelerate ocean digitalization. And the minister would like to finish his message by recalling that, as you may know, next June, Lisbon will receive the UN Oceans Conference, and the theme, increasing scientific knowledge, will be one of the themes of its interactive dialogues on the 30th of June. I wish you all a very stimulating afternoon. Thank you.
We move on to the smart cables session. The moderator is Professor Miguel Miranda, and we have our first talk. Could I invite Dr. Bruce, Professor Bruce Howe? Thank you. Thank you.
Change the present.
Good. Thank you. Good afternoon. Thank you for inviting me to this beautiful and auspicious venue for one step in moving this concept and project forward. So again, SMART stands for Science Monitoring and Reliable Telecommunications, a union between telecom and science. We are sponsored by ITU, WMO, and IOC, and we are a project of the Ocean Decade. Let's see. So this is an overview slide, and I'll spend a little time on it. First, the basic concept is to establish a global array for climate, ocean, sea level, earthquakes, and tsunami monitoring and disaster risk reduction. And in this process, we'll create a planetary sensor power internet network that is a combination of the submarine telecom cable system with science and early warning. So again, it's a union between telecom and science. Telecom remains the primary mission. Science is secondary mission. Telecom is paying for most of it. the expectation is the smart components roughly 10% of the telecom cost. And as part of that understanding agreement is that the science and sensing part of the system in no way would negatively impact the telecom portion of the system. The cable shown here, there are roughly 1 million kilometers of cable, 400 systems in the world operating today, and with roughly 20,000 of these repeaters shown here in the lower right. These are about this big, 30 centimeter diameter by a meter and a half. And they amplify the optical signals for the telecom portion. And we would add, at least initially, 3 basic sensors: temperature, bottom pressure, and seismic acceleration. We recognize we have to keep this simple to be adopted and to achieve the global scale. That's very important. And at the same time, it is a two-way street, and the data we collect with these sensors will be useful to the telecom industry as well, for specific cables, monitoring for hazards surrounding a specific cable, but then also to collect data in general to then better plan for future cables and making a more resilient network for the entire planet. If we succeed in this, we truly will implement a first order addition to the Earth and Ocean observing system. Then just finally reiterating this, the CAM system will likely be the very first smart cable system, almost 4,000 kilometers, and to be installed in 2025. And it's truly gratifying to see the enthusiasm here and over the past few years working with Anacom and the entire group to help move this forward. So all of us have seen the 2 motivational slides here. We've all seen this. The picture on the left is the increase in CO2 emissions. What's different here is simply the horizontal time scale is compressed, so we see the entire sort of industrial revolution, the exponential increase in CO2 in the atmosphere, and it's still increasing. It hasn't turned over yet, but the curves going down indicate the challenge we have to really keep temperature increase within reasonable bounds. We're trying to accomplish in 20 years what took 200 years, our forefathers started. And then on the right is the plot showing that right now 1 or 2% of the land surface is uninhabitable because it's simply too hot, and greater than 29 degrees. And if we continue business as usual, 20% of the land surface will be too hot to live in. So just imagine, the terrible consequences of that. So really, we need more observations of the ocean and the planet to help understand this climate system and then mitigate the response. And the ocean is the flywheel of climate. It's absorbing 90% of the excess heat that's being trapped by the CO2. And then also the actual carbon dioxide is being sequestered in the ocean. So we need to learn more about the ocean. Looking at earthquakes and tsunamis, again, many of you have seen these pictures on the left and the sort of composite tsunami picture, including the 1755 event, and the map on the right showing historical earthquakes with the cable systems. And the present tsunami warning system composed of dart buoys. They're roughly, they're 64 deployed and 38 were responding a week ago. And basically there's only 70% availability of those systems, and they're very expensive to maintain. So the idea is the smart cables can absolutely complement those buoys and produce a long-term reliable early warning system for tsunamis and earthquakes. Again, the table in the lower right simply indicates that we will be helping the telecom industry as well, because the more they know about the environment, the better they can do their planning. So let's just look briefly at the three variables we're saving or monitoring. So temperature, we're measuring what will be called subsurface temperature, essential ocean variable of the global ocean observing system. And in fact, measuring the bottom boundary condition of the ocean. As ocean water heats up, it expands, and about half of sea level rise is due to expansion of the ocean due to increasing temperature. And then changing temperatures also influence the ocean circulation. And then looking at pressure, ocean bottom pressure, obviously it's related to sea level. And the changes in pressure indicate how much fresh water is melting from glaciers and the ice sheets in Antarctica and Greenland, and then filling up the ocean with quote, new water. And then second, changes in pressure are indicator of a component of ocean flow. Water flows from high pressure to low pressure. And so by measuring these differences, we can infer part of ocean circulation. And then from the point of view of hazards, having both seismic information to better locate earthquakes, from which then we can make predictions of tsunamis, and then having the in situ pressure measurements to verify those predictions are essential to improving earthquake and tsunami warning. And then lastly, from mostly a scientific point of view, for the first time, we'll actually be instrumenting much of the ocean from a seismology point of view, and we'll be able to learn more about the Earth's interior. So just to sort of summarize, climate change and global warming is humanity's greatest existential threat now. And smart cables can make their, small little contribution to helping to understand the problem and thereby mitigate effects. So again, climate change, sea level rise, disaster risk reduction, and societal connectivity by improving the network, addressing SDGs and the Sendai framework. So just a little engineering technology here. This is a cartoon of a repeater. Actual repeaters are shown in the lower left, roughly a meter and a half long by 30 centimeter diameter and 400 kilograms. And likely the accelerometers will be put inside the repeater. The pressure sensor and temperature need to be external to be in contact with water, and temperature measurements need to be some distance from this little heat island that is the repeater. There are several companies addressing smart repeaters. Subsea Data Systems, a small one in the US, and then Alcatel Submarine Networks has publicly come out saying that climate change must and will be an integral part of their corporate strategy in a concrete way. One of the concrete examples they give of addressing that is providing smart capability. So the next two slides just show some of the systems under consideration. Let me start in the middle with the wet demonstration. This is, like it says, a demonstration with three packages in line in a cable attached to a conventional, if you will, cabled ocean observatory. basically to show the mechanical integration and good science return on the data. And that should be installed this year. Farther on the right is the Medusa system proposed, and it would connect Lisbon, Barcelona, Marseille, Sicily, and Egypt. Given the timescales and timelines, it's a commercial project, obviously. It may be that only the eastern part gets a smart component, but we're definitely working on doing that. And then on the left is the CAM2 system for Portugal. It is a domestic system which simplifies some aspects, and it is part of this Atlantic data gateway that has been talked about. And a primary motivation is a 1755 earthquake and tsunami. So again, Anacom has been leading the effort from the telecom side, and Leia and others, Yassar Omar and Luis Matias will speak coming from that group. And Vita Silva here has made some calculations indicating there is real financial benefit to doing this. And I'll let them give more detail on this. So in the Pacific, there are other systems under consideration. New Caledonia Vanuatu has money on the table, and there's more. There's additional funding from the Moore Foundation, not just for Vanuatu, but smart cables in general. New Zealand wants to put a cable to Chatham Islands, small island community, cheaper than long-term satellite contract, and the Ministry of Business has invited the science community to participate in the way of a smart cable there. Antarctica is presently without any cables going to it. It's the last continent that's unconnected, and the situation is really dire there. They have 100 megabits per second only to the main U.S. base, and so the U.S. National Science Foundation is investigating putting a cable in there and then understanding that the cable should be smart. It's incredibly, let's say, rich area from an oceanographic point of view and climate change to include sensors in the cable. And similarly, in the Arctic, Arctic Express is working on getting a cable system going between Norway and Japan through the Canadian Northwest Passage. Indonesia is working on this. They obviously need as much help as they can get for tsunami and earthquake early warning, and they're taking the approach of trying to develop the technology in country. So just in conclusion here, the smart system will be measuring essential ocean variables and contributing to disaster risk reduction. Consider a global scale, power plus internet on the seafloor, sustained real-time 25-year life, highly reliable, leveraging this large industry with centuries of experience and producing low lifetime costs. There will be smart capability available, and I've mentioned systems in progress. And I see that the smart CAM system will catalyze many subsequent actions, and Portugal can lead this global endeavor by example. Thank you.
Thank you very much. Thank you, Bruce, for your very interesting communication. And now is the time for Yasser. You are there.
Okay, so hello everybody, good afternoon. Thank you very much for, yes, sorry. Should I put it here? Okay. So thank you very much for the kind invitation and congratulations to ANACOM and the co-organizers and the Academy of Sciences for putting together this very interesting session. Very happy to be here and to contribute. Shall I start? Okay, so I want to tell you about our project or initiative called LIA, Listening to the Earth Under the Atlantic. And so the message I want to convey is that our planet is alive, okay? So here in this plot, you can see these red and yellow dots showing between the year 2000 and 2008, where earthquakes happened. And as you can see, most of them happen at the bottom of the ocean, under the sea. And, you know, we had a recent reminder of how alive our planet is with this Cumbre Vieja volcano in the Canary Islands. So lots of activity is happening. Sometimes, as we saw in the Canary Islands or in other unfortunate events, we see it, but most of the time we don't see it. And when we see it, unfortunately, it can have devastating consequences, right? Like this infamous earthquake in Indonesia, followed by a tsunami that was terribly destructive. How can we measure this? Can we predict this or not? And so one way to measure this seismic activity at the bottom of the ocean is literally to sink a seismometer to the bottom of the ocean. And you see here some so-called ocean bottom seismometers developed by Carlos Quarella from Instituto Dom Luís from the Faculty of Sciences of the University of Lisbon. So let me zoom in a bit. So this is developed here in Lisbon, and you can see at the bottom essentially is a weight, and inside this orange capsule is the actual seismometer. And so the idea is that you submerge this, you go by boat to the right places, you submerge this, you leave them there for 6 to 12 months, and then you literally fish them out. There's a hook here to recover them. And so you get some data, but this data is not live. This is data that is at least 6 to 12 months old. And so this is interesting for scientific research, but not so useful for you know, immediate monitoring and reaction. And furthermore, these ocean bottom seismometers, they're fragile, and they're quite expensive to deploy and retrieve, and they have limited coverage. As you can understand, the logistics is non-trivial. And so it's estimated that if you wanted to roll out this technology at a global scale, this would be the order of billions of euros. But the key point is it's not real time. Could we have something real time? Well, you could have these bottom sensors connected to some buoy system that would then retransmit this information. But again, these systems are not very reliable. They're expensive, but they're not effective. So they're fragile. And again, the coverage is limited. And so what are the problems? So these buoy systems, including tsunami warning buoys, are vulnerable to meteorological phenomena, to people who steal their parts. They steal the batteries or steal the GPS, etc. And then there's just natural deterioration or even vandalism. And unfortunately, this example of the Indonesia tsunami, none of these buoys worked. So I have this piece of news from BBC. Let me read. Tsunami buoys were given to Indonesia a decade ago to improve the early warning system for tsunamis. None remain functioning. So 0 of them work. So this is not a reliable system. And also, even if they work, how accurate are these predictions? This unfortunately is hard to get, right? And so here's a more recent example from an early warning for a tsunami alarm after an earthquake that was sent out in Chile that was turned out to be a false alarm. And so this then creates panic in the population, and you know, the system loses credibility, and then this is a very hard decision. You know, there was this earthquake, our systems are telling us that maybe there's a tsunami coming. How much can we trust this system? Do we warn the population and maybe we save them? Or maybe we create a false alarm and then people panic and there are consequences and they lose credibility in the system? Or we don't warn them because we're not sure, and then we didn't warn them and a tragedy occurred, right? So the reliability is also a big issue. And here's this example where Chile regrets the panic caused by mistaken tsunami warnings after an earthquake. So what we have here, and this of course has been alluded to in the previous talk by Bruce, and of course the whole introduction and the whole nature of this session, is the unique opportunity to use telecom cables as scientific sensors, and in particular seismic sensors. And there's this unique opportunity of the CamRing, which is a new infrastructure to connect continental Portugal to the Azores and to the Madeira archipelagos by telecom optical fiber cables, and to equip them with scientific sensors, right? So the idea is to use this telecom infrastructure to have a real-time underwater observatory in the Atlantic by attaching these geophysical and environmental sensors to these repeaters in the submarine cable. So we've already seen some images by Bruce. I have a few others. You can see them by yourself in this exhibition at the Museum for Telecommunications. It's a very nice exhibition, the submarine cable in a sea of connectivity. I think this is the previous iteration of the exhibition. I think it was renewed. I believe it's still available, visitable. I strongly recommend, and I congratulate the organizers and curators of this really interesting exhibition. And in fact, there's also historical aspects that you can see in this exhibition and realize that Portugal played a historical role in submarine telecommunications more than 100 years ago, and in particular the Azores islands, who were more or less in the middle of the Atlantic between Northern Europe and Northern America, played a key role. And it's very interesting to visit both here in Lisbon and in the Museum of Horta in Faial, all this revolutionary technology at the time that allowed telecommunications. So Portugal now may play a role in the future, also play a role in the history of submarine telecommunications. And so this is essentially the key idea, to merge two well-known and existing technologies into one new, never used before technology, which is we have submarine cables for telecom and the corresponding repeaters. We have scientific sensors. Now we want to put the sensors inside the telecom repeaters. And so this is the big effort that is being discussed here today. I also want to mention an additional idea, complementary idea. This is still very open-ended. This is still ongoing research, which is to use interferometry of the light that is sent through these optical fibers at the landing station. So everything is done on Earth, and to interfere and measure the interference in these signals of light that depart and arrive at the landing stations of the submarine cables may allow us to detect also earthquakes. There are some preliminary results showing that this idea works, but it's still very preliminary. It's still to be proven that it could work in long distances in the Atlantic Ocean. So the experiments were done in optical fiber without repeaters with a length of 90 kilometers between southern Sicily and Malta, in a very calm sea, which is the Mediterranean Sea. So it's still to be proven that this is a technology that would work in more in other circumstances. But should this work, this would be revolutionary, because you don't need to change the infrastructure. You don't need to deploy smart cables. Then every millimeter of the existing, million kilometers of cables could potentially become a sensor. But let's see what happens. And Portugal is involved in this and can also contribute, should we get some support, to these applications. And so, I also want to mention applications to the study of the ocean and to the study of climate, because ocean circulation, both at regional and global scales, influences the climate, and also potential applications to monitoring marine protected areas, or even marine biology and ecology. And I want to give a shout out to Álvaro Peliz at Instituto Dom Luís, who's contributing to our efforts in this front. And so this is why we created this initiative, LIA, Listening to the Earth Under the Atlantic. So this is a joint initiative of three institutions: Instituto de Telecomunicações, Instituto Português do Mar e da Atmosfera, and Instituto Dom Luís, and inspired by the vision of ANACOM on smart cables and the new CamRing. We've been working together on this topic since July 2018, so almost 4 years ago. It's been a very interesting and fruitful multidisciplinary collaboration. And so the goal of our project is, first and foremost, to investigate the use of submarine cables, namely telecom cables, for real-time scientific monitoring and seismological and oceanographic data. Then we also want to investigate the applications to civil protection, in particular to early warning of tsunamis, and of course, potential applications also to climate change studies, marine biology, etc. We want and have advised authorities on technical specifications for what this new technology could be. And we also want to promote outreach based on ocean bottom live data. This is a spectacular educational and outreach potential to have the first real-time submarine scientific observatory feeding data into a museum or into a laptop and having schools and kids engage on this. And we are very open to collaboration. So I skip this because I'm running out of time, but the leadership of Professor Bruce Howe has been, key in developing things at international level, at the UNESCO level, IOC level, and also supporting our efforts here. So thanks again, Bruce, for your leadership on this. And so I just want to finish that showing the infrastructure. We have these ongoing or establishing new collaborations with a bunch of stakeholders to continue these studies. So I want to show the team of people involved here and just quickly tell you about the potential impact of a smart cable for the CAM infrastructure. So I skip this, you know it. This is a very seismic area, so you can see Portugal and the Azores on your left, and here in the middle, the Madeira. I don't think I can point there, but I'll skip that. So, we are, of course, in a very seismic area. This is IPMA's seismic sensing network, and as you obviously understand, this is all on land. So there you can see Azores and Madeira. And IPMA has the responsibility for the earthquake monitoring and tsunami early warning center for the North Atlantic. And imagine now, besides the sensors that I showed you before, we also had these red triangles there that could be the future smart CAM sensors. And so Luís Matias, who is here and he will speak next, and from EDL, and I'm about to finish, and Fernando Carrillo from IPA, they made this simulation and they said, imagine we had a smart cable for the CAM infrastructure, and this famous tsunami from 1941, we would have had a 36-minute gain for the early warning. And then maybe closer to some people in the audience, the 1969 tsunami alert here close to mainland Portugal. With this infrastructure, we would have had a 12-minute gain, which of course can make the whole difference in terms of protecting the population and infrastructure. And so to summarize, so the goal is to establish a permanent real-time underwater observatory, which to the best of our knowledge has never been done before. So Portugal would be pioneer here and would benefit from all the scientific, strategic and technological aspects of this leadership. This could be a revolution in the early warning of tsunamis and seisms and for civil protection for Portugal and of course for the entire world. We want to share and collaborate on all these fronts. A unique competitive advantage and leadership for Portuguese science and civil protection, and a public service to national and international communities, and an example that could be replicated around the EU. We have contacts with the Joint Research Center of the European Commission and to the world. So thank you very much, and this is what we propose: listening to the Earth and the Atlantic, or seeing the Atlantic as you've never seen it before from the bottom. Thank you very much. Sorry if I went.
Thank you. Yes, sir. You were very fine on time. Now it's Luis. Okay, you have the same 13 minutes. You know that I am.
So, good afternoon. Here I'll present some of the applications of the SmartCam, namely the contribution for earthquake monitoring and tsunami early warning. And you'll see some applications later on oceanography and also on earthquake early warning. So I don't know if in the United States they say cut down to the cheese or something like that. So let's go to the cheese. Oops, no. Okay, so Portugal is a dangerous place, at least in the long term. It's a dangerous place because we are in the frontier, or close to the frontier of three major tectonic plates: Eurasia, Nubia, and North America. So this area is responsible for a number of tsunamis, which are shown here. 4 of them, which were recorded, and some of them also observed on land, occurred in 20th century. So in the 20th century, we have, it's not only 1755, but also on 20th century, we had four tsunamis in this area. So for offshore earthquakes, so most of the most destructive earthquakes in this area occur offshore. So this is a serious problem for the national network system, which operates only on land stations. So I'm going to show one example. So in 2007, there was an experiment where we deployed, international cooperation nearest, deployed 24 OBSs, and we were able to compare the events that were recorded in the Gulf of Cadiz. So in the red, you see the locations with land stations, and in the red, you see the locations with the ocean bottom seismometer. So you see a considerable bias. So it seems that the earthquakes are attracted to the land network, and most seriously because it affects also the message that is sent for tsunamis. The depth of these events were really completely different from the ones that were seen from the land stations. So as regards tsunamis, a few years ago, there was a paper published where we measured the alert time that is available when a tsunami occurs. And if there are no offshore tide gauges, so no offshore sea level, we see that a considerable in gray, a considerable coastal area in Portugal will not have enough time for evacuation. So at the time we considered three buoys. We were thinking about 3 buoys, and these 3 buoys, which were located considering reliable sources for tsunamis, these 3 buoys contributed to a significant improvement of the alert time that was available for the coastal communities. So there is no gray areas anymore there. So earthquake and tsunami observation are in trouble for observations. So indeed, we need offshore sea level and earthquake monitoring, as was shown also before by Yasser Omar. So dedicated cables exist in Japan. Even the states, they are too expensive. They are considered too expensive for this kind of purpose. So the smart cable is a new option which uses new cables, and that so the seismic or scientific observation is leveraged by the telecommunication. So I'll speak only about smart cables, but listening to the Earth under the Atlantic, as Yasser mentioned, is also concerned of all technologies that are available for submarine cables. And I added just the fourth one. Yes, the third one. No, there is another one. Okay, the fourth one, which is below. I just added a few days ago because we heard about this new technology. So the results I'm going to present here have already been published in 2021 and 2022 by 2 papers in the Journal of Frontiers. And so this is the design of the cam ring of the telecommunication cable, and the procedure that we use to test how the smart cable can contribute for earthquake and tsunami monitoring and early warning is the following. So we define the area and the sources to be investigated, the rules for fast evaluation of earthquake and tsunami parameters, define the background scenario, compute relevant parameters, define the scenarios with cable observations, and compute and finally evaluate the difference between the cable and no cable observations. Okay, this is the scenario. So we considered all these possible sources of earthquakes and tsunamis. This is the scenario database that is available at EPMA for tsunami warning. And here we show the land stations that can be used currently to monitor these sources. So you must think that EPMA must send a message on the location and magnitude, location and the focal depth after 6 minutes of the origin time. So they cannot wait for too many stations. So the rule there is that after data is collected by 10 seismic stations, then the operator is able to issue the first message. So this is in this first message that I'm going to work to improve this really first message. Okay, you can have later on further analysis, but this first message that is crucial for civil protection applications. So this is the scenario that we use in this publication. So we consider 47 UCUS means universal cable observatories. So sorry, this is not well formatted because changing machines it did not format well, but so I apologize for that. And in the red you see, so you see the stars are major earthquakes, magnitude larger than 7 that were occurred since 1900 in an offshore area. And for the 1755, I don't show any epicenter because the structures are too large, and I show in the red the sources, the structures, the faults that have been attributed by the scientific community for the origin of 1755. But remember, if in 1755 one of them rupture, then all the others remain and can generate large earthquakes and tsunamis. Okay, so how do we measure the improvement on earthquake location, fast earthquake location? So there are several parameters. For instance, travel time, I'll show you later on. The gap, which is the azimuthal, maximum azimuthal difference between two stations. Also the DU, which considers also the homogeneous distribution of azimuths. This is very important for the quality of earthquake parameters. And then you have some quality parameters related to the location of the event themselves. Okay, the first three only depend on geometry of the network, but the other two depend on the quality of the peaks, on velocity model, how correct is the velocity model. So we need a different strategy to evaluate the quality parameters related to the location of the earthquake. Okay, so this is, so for these location parameters, we relied on Monte Carlo simulation. So we run 100 models where we randomize the peaks of the waves and we randomize the velocity model because we don't know it. And then we measure the difference between the centroid of this cloud of one other locations, and we measure the uncertainty by the ellipse, by the error ellipse computed by the covariance. So this is the improvement on the gap, which is the azimuthal difference between two consecutive stations. So in red is good. So it means that there is a considerable improvement in gap in these red regions. So Eastern and Western Gloria Fault and also in Southeast Portugal. This is for the other geometrical parameter. And then I'm going to show you the difference between the locations with the Monte Carlo simulation. So this is with only land stations, and this is with the cables. Oops. Oh, I would like to go back. Sorry. Okay, just to show you again the difference. And then the difference, which you see that is mostly concentrated on the western side of the Gloria Fault, and then the uncertainty. So these clouds show all the 100 locations generated by the Monte Carlo simulation. So you see that without cables, there is a considerable uncertainty, and with cables, so with cables. So a considerable improvement that is also evaluated here, so concentrated also on the eastern and western Gloria Fault. So you see, so the conclusion is which are the areas where you see most improvement by the cable. So you can see it is the eastern and western for most of the parameters, and it is on gap. You see, sorry, on the distance between centroids, it's concentrated on the western Gloria Fault. So now the computation of the time required for the first 5 stations. So EPMA has already in testing mode an earthquake early warning system. They work with the ground motion from the 5 first seismic sessions recording the earthquake. And this is the gain in this time. So you see the scale is in minutes. So several minutes in gain for the earthquake early warning. So the size of the symbols say which were the sensors that most contributed to this gain. So Vitor Silva will elaborate on this, on the quantifying the gain that is obtained from this. This is seconds, for these few seconds earthquake early warning. So for tsunami monitoring, I have to tell how it is done. So with this first location, 6 minutes after the event, the EPMA issues a first alert on tsunamis if it falls inside the decision metrics. But there is no confirmation. So we have heard a little while ago about false alert. So there is no confirmation. With the current coastal tide gauges, confirmation only happens when it is recorded on one coastal tide gauge. It means the areas closest to the tsunami source will not receive a warning or a confirmation or a cancellation in time. So for this, we computed the gain in this case, the scale will be minutes, the gain in tsunami travel time obtained by the cable. So this is the network without the cables. Remember the gain in warning time that was already computed. And this is the gain in minutes in tsunami travel time obtained with the cable. So you see a large gain in minutes, which were already mentioned in the Yasser presentation a while ago on 2 examples. So this is for the whole area. So most of the active areas will be benefit, or source areas will be benefit from the tsunami, from the cables monitoring sea level. Okay, so conclusion. So the conclusion, I wish to show this slide, because the SmartCam is not a bottom-up system, as was shown by Bruce. It means it's the scientific and the community that is raising funds and support from the government. This, in Portugal, it happens top-down. It was the CEO of Anacom, so I'm sorry he left already, because I wanted to thank him very much. So it was him that brought these smart cables to the community, and we just followed. So we followed the ANACOM, the regulator, in evaluating what is really the gain. But it was already decided. So they managed to influence the government to approve, and a consequence of that is that in the next budget, we hopefully will have funds for the smart cable. So that's all. Thank you.
Thank you very much, Luis. Now, anyone on the floor wants to raise any question? Zuzia has a microphone, and all the speakers will be happy to answer to Mario. I see that you have the impulse, no? Is there any question on the chat?
Just checking now.
So, anyhow, let's speak on time, because, you know, some of us are waiting for this kind of stuff for decades. So what are the ideas on the scheduling? When could we have a smart cable operating? Yes, sir. Or you know, you already had me there, sorry. Anacom.
What we are expecting is to have the proposal for the budget for this year for the new government, once again the indication of the smart cam. Then, if the governments will deliver this job to IP Telecom to order smart cam, what that can happen in terms of time frame, we will have the order issued somehow during this year. If we'll have it, perhaps, let us say in June, perhaps a contract could be signed at the end of the year with a supplier. That means we'll be, if that normally takes 2-3 years to have the cable implemented, I should say no later than 2025 that we can expect the smart cam to have smart cam in operation during that time. Of course, it will be very nice to have it during 2024, but I do believe that it will be very difficult to accomplish that, because the time of suppliers to have industry responding to this will be very difficult. And also there is a problem of congestion on ships to install this cable. Fortunately, we do believe that the actual cam ring will be a very old system by that time, but still in operation. That means the telecommunications between the mainland Portugal and the Azores and Madeira could be assured. And in parallel, the new cam ring will be developing and will be installed with some months delay, but still in time to have the new cam ring in operation, if not possible in 2024, at least during 2025. But once again, that will be depending on the signature of the contract with the supplier, and we hope that this can happen during the current year. Thank you.
Thank you very much for your answer. I would like to have a second question on Yasser. What are the biggest challenges from the IT point of view, from the telecommunications point of view? What are the big challenges ahead?
You mean for the smart cable?
Yes, yes. No, for all the technologies that you can develop above the smart cable.
First of all, I'm not really an expert in classical telecom, so maybe some other people here in the audience can answer better. To the best of my understanding, also I'm not an expert in seismology, right? So I'm probably the wrong person to answer this question. My understanding is the telecom technology on the one side and the sensing technology on the other side is not new, is well known, is well tested. What is new here is to bring them together, is to put these sensors, which in fact also have been deployed in submarine systems, but not telecom systems. So dedicated submarine networks, these are quite rare and expensive, but they do exist around Japan in the west coast of North America. And so to have these submarine sensors that we know work well and put them in telecom submarine repeaters, which by themselves we know work well. And so now this is a challenge for the manufacturers to bring it together. And I think after some initial skepticism, I think now the industry is picking up on this and they want to start providing this. So I don't know if there's any industry representative here who maybe could answer better. I also take this opportunity that you asked me this question to apologize. I have to leave in a few minutes because I need to give a talk at the Institute Supertechnico across the town. So I'm sorry, I told the organizers about this before. So unfortunately, I'll have to leave very soon. I'll try to come back for the final discussion if I can make it. Okay. And also, since I have the microphone, I want to tell you that I want to introduce Rita Nunes, who's a famous Portuguese film director who is sitting there. And she's actually, she can tell you about it in the coffee break. She's actually developed a fiction film, which is already being funded based on the smart cam and a seismic event and making a fiction story about this, but informed by the experts. And so Luís Matias, Fernando Carrillo, etc., are informing so that this fiction film not only features this new futuristic infrastructure, but is well informed from the scientific point of view. And finally, I also wrote a proposal for a documentary about this that together with Rita, we're going to submit apply for funding. And so if you have the occasion to talk to Rita, it would be very informative for her to know the people, know your questions, know your answers, and potentially contribute to this documentary. We want to show this new science and this new technology as an outreach project. So I'll pass then to the colleague from, no, you don't want to answer?
No. So thank you very much, Yasser. I think that we can now move to the coffee break, with the exception of Yasser, that of course has not the right to go to the coffee break because he's leaving. And we should be back by 16:15, 5 minutes earlier, to start our next section on time. Thank you very much for your patience.
My name is Martin at the Portugal, working at the Geographic Institute. I'm an hydrographer, and I will be sharing some notes about smart cables for oceanography applications. This is the agenda. We'll speak a little bit about the Hydrographic Institute, oceanography, and the oceanographic applications, and I will finish with some final thoughts. This is the Hydrographic Institute. It's located in Lisbon, in the heart of Lisbon. But we do have an hydrographic base in the river where we have our equipments and platforms. And we depend on three ministries: the Ministry of Defense, Ministry of the Sea, and Ministry of Technology and Higher Education. I need to remove something here, I think. So, just a legal review. We are part of the Navy. We are the hydrographic office in Portugal, and we are a state laboratory. So we are integrated in the Portuguese Research Laboratories Network. We regulate the hydrographic cartography, and we are responsible for nautical cartography. As I said, our area is pretty wide as we deal with defense, education, technology, and of course, the sea. Okay, so it moved. So our maritime areas of interest are obviously the Portuguese Sea, which is pretty wide, and showing the world. You can see that it's not only that, but also some parts of the sea in Africa in orange, you can see there. And that's because we work together with some countries. So we need to work on that sea also. So as I said, nautical cartography, hydrographic cartography, and to do this, we use our own data. So we use hydrography, oceanography, geology, and marine chemistry. And this is our areas of work. So the scope of marine information that we work with is pretty wide, as you can see there. And to do that, we have a wide area, a wide deal with of sensors spread around the Portuguese Sea. This is oceanography, and I want to talk a little bit about some equipment, some specific ones that are important for this talk. So this is the acoustic Doppler. Sorry again. Acoustic Doppler current profiler, which measures currents, and we have, you can see there, a structure that we use to place the oceanographic equipments on the seafloor. So another thing I want to point out is that the world is moving towards autonomous vehicles, and so are we. So we have AUVs, USVs, gliders, etc. All of them are working as a standalone, and they need to be positioned somehow. And some cannot use GPS, so they use acoustics. And now I'm moving finally to oceanographic applications. And I brought this first image, which most of you already know very well. And I want to point out the cam, of course, the cam ring, which is of most interest for us. And this is the way we see our working place. But if we try to see the submarine cable, we can now use the sensors that we want on the seafloor. So obviously, the ones that we have talked already, temperature, conductivity, what else? They are pretty much, everyone has talked about them. So they're common, and of course they are important for oceanography. We can know the sea with them, but I would like to stretch this a little bit more and go for newer things. So the idea is, why not using the ADCP on the seafloor and connect it to a repeater? Okay, this way, we would be able to monitor the currents from the seafloor to the sea surface, if possible, at several places along the submarine cable. Another thing is, when you lay down a cable, you have to do an hydrographic survey to understand how the seafloor is. And of course, for the maintenance of the cable, this hydrographic survey is also needed. And it is done with AUVs usually, and they need to be positioned, so they use acoustics. They do the survey along the cable. So why not to use transponders along the cable? And this would allow the AUVs to be positioned all the way through the cable. And this is an image of a survey where you can see the cable on the seafloor. One new equipment we use pretty much every day. It's a single beam echo sounder, and it is used to see the seafloor, to measure the depth. But nowadays it also measures everything. Well, it also shows everything that is in the water column. So if we face a single beam up, we will see everything that is in the water column. This would allow us to see the sediment displacement everywhere where we want it. And there's an image showing the sediment displacement with a single beam. And finally, this is submarine network management system. It's a conceptual image, of course, but what I wanted to point out here is we can use an acoustic modem placed on the repeaters, and that would allow us to control the AUVs in pretty much real time. And this is all the equipment that I've talked about. And some final thoughts. So as I said, temperature, salinity, pressure, this shows us the ocean, and of course, tsunamis. The ADCP would show us currents, transponder for positioning, single beam echo sounder would show us sediment transport, and the underwater network management system using acoustic modems would allow us to control the autonomous vehicles that would be surveying for us. Now, the challenges are obviously technology and depth pressure. As the equipment do exist, the repeaters exist. Now we have to be able to connect them and to use those equipments at higher depths than usually they are used. And thank you very much.
Thank you.
So now we call the presence of Vitor Silva from University of Aveiro. Please.
So, okay. Thank you very much for the invitation. My name is Vitor Silva. I'm a researcher in Aveiro. Okay, let's see if this is working now. It seems like it is working. So the idea of this presentation of this part of the study, it's actually not just to look at warning times or if this is expected to work or not. I think we had presentations about that previously, but actually to try to understand how can we convert this into money. A lot of times we have this nice ideas, scientific ideas, but sometimes people ask me, are we going to be able to save some funds? I mean, obviously saving the human lives is quite important, but we know that the economic benefits are also quite important in this kind of efforts. So basically, we have to take into account that such a system, an earthquake early warning system in Portugal, would not always provide let's say, true alerts, correct alerts. So we have to take that into account. What are the districts where a system like this would be beneficial? What are the type of gains in, where are these gains coming from in this type of assessment? So basically what we did was to look at earthquake catalogs, historical catalogs, synthetic catalogs, instrumental catalogs, basically trying to look at all the previous events that happened in Portugal, even if they were centuries ago, as well as possible future events that might happen in the future. So basically take into account existing seismic hazard models for Portugal and understand which events basically would give us, let's say, a good time, a good warning time, and what are the events that where this wouldn't happen. So for example, let's assume here for a second that we have already our CAM, our ring, the submarine cable over there. I'm also taking into account the stations in inland Portugal. They were provided by IPMA. So we're taking into account both stations. And for example, we have over there a magnitude 7 southwest of Portugal. So we do take into account all the sources of uncertainty because we basically contacted colleagues from Mexico, from Japan, from California, and they give us their models just to understand what is usually the uncertainty around magnitude and distance. And for example, we start taking into account how much time basically seismic waves would take to arrive to the closest stations. And then we also did an evaluation of how many stations do we need in order to trigger such alert. So if an earthquake happens, I wish I could tell you that basically the system would always predict a correct alert, but it's not the case. A lot of times, basically, we know that no alert would be issued because the earthquake is just too weak. Sometimes we would have false alerts. Basically, the earthquake was not strong enough, but the system decided that maybe it should be triggered. Also missed alerts. But what we hope is to have a lot of correct alerts. So basically the earthquake was strong enough and the system was capable of detecting the earthquake. We analyzed all of these variables, and I will not go into detail on the scientific aspects of that analysis, but I just want for you to focus on some of the results that we have here, specifically for Lisbon, and then I will show also some results for Faro. What we have here on the top is different levels of seismic acceleration. So basically, should we trigger this alert when there's only a little bit of shaking in Lisbon? Okay, and this means that we would be bothering the population a lot of time because only a little bit of shaking is necessary to trigger this alarm. Or should we actually rise the threshold and we're only going to alert the population if the ground shaking is very strong and it's basically capable of causing damage, even in modern construction? So if you look at the bar plots on the right, you can see that if we use a very small level of ground shaking, then we have a lot of correct alerts. Okay. If we start increasing the amount of ground shaking that is necessary to trigger such alarm, then the correct alerts will decrease. We have more, basically no correct alerts, but we can still see that, for example, for the case of Lisbon, we would have a lot of correct alarms. So basically a lot of times the population would be warned and there would be a worthwhile alarm. These are just the results for Faro. Faro is basically closer to all these offshore earthquakes that we can have. This is why we would be able to have even better results for the city of Faro. And this analysis were performed for all the districts in Portugal. This is just a view for all the districts in Portugal, again, for different levels of acceleration, going from 0.05 G, so something that is very small, but might still be capable of causing damage, for example, in old masonry buildings, like a lot of the buildings that exist here in Lisbon. And then we increase the ground shaking until something that would be capable of causing damage, for example, in reinforced concrete buildings. Now, what about the lead time? We've seen already some lead time, the warning time for tsunamis here today. What happened, for example, for the ground shaking? So I would actually like to show you this with two examples of past events that happened here in Portugal. So we have the 1909 Benavente earthquake, so very close here from Lisbon, so more or less 100 years ago. But we also have the 1969 Algarve earthquake, magnitude 7.8, very different events, you know, rather small magnitude, but very close to Lisbon, and then offshore event with very strong magnitude. So for these two cases, with the system that I'm describing here, already with the submarine cables, already considering the smart repetitors on the undersea cable, in green, you see the districts where an alert would be issued. Okay, so for example, for the event in 1969, we can see that the southern part of Portugal, Lisbon, Setúbal, Alentejo, Algarve, Santarém, there would be an alarm being issued to the population in these districts. And what about the warning time? Well, the problem that we have with a very close event, like the 1909, just a magnitude 6, is that basically the warning time would arrive too late. Basically, people would feel the earthquake and then they would get the alert because people would be just too close to the epicenter. But if you look at the event on the right, the 1969 earthquake, the magnitude 7.8, this is a very nice example of how such a system might provide very valuable warning time to the population. So for that event, 1969, the population, for example, here in Lisbon would have 20 to 30 seconds. That's a lot of time before the destructive seismic waves would arrive here in Lisbon. So if we take into account not just two single events, but actually everything that might happen in Portugal, then this is the results that we have. Okay, so this is basically the average annual number of correct alerts. Okay, so annually, obviously, the number is very small. You have to think about the systems that they would be working for example, for 25 years or 50 years. But these results are telling us that if we consider the entire seismicity in Portugal, such a system would be worth in the districts of Faro, Setúbal, Santarém, and Lisbon. For the other districts, this might provide some benefits, but the benefits would be very rare. If we also move in terms of the warning time, we can see that for the districts that I just mentioned, usually people would have between 20 and 30 seconds of warning time. So what about converting this into economic benefits? How can we turn such a system into economic benefits? How can we save money from having such a system? So there are many ways that this can have benefits, and a lot of these benefits have shown in countries like Mexico, like in Japan, and a little bit more recently also in West of the United States. But basically, you can issue public warnings to the population so they can basically duck, cover, and hold. Okay. For smaller buildings, you can also evacuate the building because you have between 20 and 30 seconds. There's been examples like that in 2011 in Japan, where basically students managed to evacuate the school because they knew they had enough time to leave the building. But there are other ways that you can save some funds. For example, if you stop industrial processes. For example, we have the big complex system in Sinj. So some of those procedures might be stopped. You might close some valves to make sure that you don't have these industrial accidents. You can also slow down trains. This is already done in Japan quite commonly. And if the trains do not derail, then you know that you will not disrupt the economy. And then you might also, for example, start energy generators in healthcare facilities or stop some surgeries if they're too delicate. We only focus on the protection to the people. So basically, we had already an exposure model for Portugal. So the location of all the residential buildings, commercial buildings, and industrial buildings in Portugal, this was given to us by the statistical office in Portugal. Then we repeat many, many events, and we took into account that during the day, we don't have as many people inside of the buildings, and during the night, we have more people inside of the buildings. So the impact during the night of earthquakes in Portugal would be stronger because we have more people and residential buildings, which tend to be more fragile in Portugal. So this is what we do. We generate many, many earthquakes, and then we test the system. Maybe the system will issue an alert, or maybe it will not. If it doesn't issue an alert, then I'll just proceed and I calculate my losses normally. If it does issue an alert, then I take into account the size of the building. If it is a small building and you had a lot of time, people might be able to evacuate the building. If not, if the building is too tall, or for example, the lead time is not sufficient, maybe the injuries will be reduced, but not by a lot. Okay, so I would like to show you now the results. So the results depend if it's during the day or if it's during the night. And I will show here the example with the earthquake early warning system and without the earthquake early warning system. So during the day, this is basically what we call the average annual population that would be severely injured, critically injured, and fatalities. Here's the example for the results for the same events, but during the night. So we can see that during the night, we expect more fatalities, more people would be injured because there would be more people inside of the buildings. And with the earthquake early warning system, we can see that there is a reduction. Okay, this reduction doesn't go obviously to zero because we still have many events where the system might not be able to predict or to give you a correct alert, or it does give you a correct alert, but we also take into account the reaction time of people. Okay, usually people take 8 seconds to take action. So if the lead time was not sufficient, we would still have some fatalities and injured because people didn't take cover. So what about how can we convert this into let's say, economic gains? So we assume that the system would be working for 25 years at least. Then we assume that seriously injured patients would be in the hospital for, let's say, at least 30 days. And because of the current pandemic, we actually know how much does it cost to have a person in a hospital per day in Portugal because all this information was released. We also assume that critically injured, they would have to be in the ICU unit for 30 days, and then they would be moved to the normal infirmary for 60 days. And in the ICU, in the intensive care, at least half a year ago, the cost was close to 2,000 euros per day to have somebody in healthcare unit. Finally, we also have the fatalities and how much does it cost a human life in Portugal? When we did this study, we were not sure how much was that in Portugal. So we used the value from the United Kingdom, which was 1 million euros, and we reduced that by half for Portugal. But in the meantime, we actually discovered how much the government considers for the cost of human lives. And it's actually very close to 1 million euro as well. So take into account the fact that what you see on the left, it's the reduction in the human impact. So basically, in the next 25 years, we would have a reduction in 1,000 people on average. Okay, I want to repeat this, on average, because obviously you can have a very strong event and then the benefits would be massive because the reduction in the human impact is much higher than this. But on average, you would have something like this. 1,000 people that would be on average saved, close to 300 people critically injured, and close to 200 fatalities. If you now apply these costs that I mentioned previously, then you can see the savings on the right for the seriously injured, critically injured, and also fatalities. So in terms of vertical rewarding system, assuming this 25 years, there would be savings of 35 million euros due to the injured, and 83 million if you consider the fatalities. So we computed this values, take into account what I want to believe recent data sets and recent models for Portugal. And only after I was made aware how much does it cost the installation of the submarine cables and the smart component of the submarine cables, but only take into account the human impact without bringing the gains from derailing of trains or take into account, for example, stopping industrial facilities. It just seems like just the human impact alone is sufficient to justify the installation of such a system in Portugal. With that, thank you very much.
Thank you. Thank you. So now is the time for
Ora, boa tarde, good afternoon. It's a pleasure to be here. It's a great responsibility as well. And this room talks for itself. Being here discussing a subject like this is indeed a high point in anyone that want to discuss this scientifically and in terms of, well, markets, businesses, whatever. I would like to start to address the subject in probably not a different way, but a more broader way. So when I applied the word blue to my presentation, I thought not only about the sea in itself, but also about the sky above and everything that concerns that column of sovereignty that this broad area that we are responsible for means. Basically, you have seen this slide 25 times today. It's still true. So we have a very big area to explore, to be responsible for, and naturally to make of the best way for Portugal, for Europe, for the humankind. And when we think about all this area, actually it's easy to project this area over Europe, and we will see that is more or less the same size. We think, how can we convert these in value? So what do I have to do to convert these in some way that brings value special to Portugal and to to our science, to our market, to our people. Well, let me start to say that everything that we have seen, for instance, that I have seen, because I failed being here in the morning, and I'm sorry for that, but in the afternoon, we have seen two different presentations that were addressing basically, although different, the same thing, data. So in the first one, we saw technology items that provide data. In the second one, we saw how to use that data, in this case, to protect populations in the case of earthquake or I actually forgot the word in English for a maremoto, but tsunami, yeah. Anyway, so basically we saw two different ways of one producing data, the other one to use data. When we think about the world today, we see that everything is about data. So we are virtualizing the economy. That's when we start to talk about digital economy. What we are talking about is data converted in information, information converted in knowledge and value. That's exactly why we say there that maybe we should look to this in a future perspective, what starts to be this idea of metaverse. So a virtual conception of the world based on collections of data from different sources that can be explored directly through the planning and capacity to explore natural resources in itself, but also the data. So the data is having a strong value, bigger every day, and we can see that when we look to the stock exchange market, for instance. Like 20 years ago, the most companies there were based on actually on resources, natural resources areas, and today is about digital. All the top 10 are digital companies. So that kind of puts us thinking, how can we conceive the usage of all this area that we were talking before, this economical zone that we consider to be our maritime zone, in this new, how do you project this in this new world of data? And I can ask, if we collect all this data and we sell it, we use it for better planning, for our different aspects of sovereignty, how can Portugal compete with what's Facebook, Google, Microsoft? How can we position ourselves to be part of this virtual data world that we are constructing right now? Well, we know that the new world is data, and internet is the base of it, and internet is not only on the clouds, it's mostly under the sea. All of you have heard this several times before. And that Portugal is geographically well positioned to have a relevant role in this new connectivity world that allows this new virtual economy to happen, not only through the sea and the capacity that we have to land submarine cables in Portugal, but also through the land connectivity, where just very recently we have observed that actually Portugal is a hidden gem of this inland connectivity, connecting Portugal to the rest of Europe, being probably one of the 4 main gateways in the future to transport and collect data from other continents to Portugal, and to Europe. Basically, when we pick that geographical special position and we think about the submarine cable landing planning for the next years, moreover, the ones that are not yet planned but will have to be planned very soon, especially all that capacity that lands now in the United Kingdom and has to be resolved because Europe will not want to have one of the main gateways of data entry in Europe entering by a third country. So we will have to rearrange that data distribution there. But when we look at it, we clearly see that the new coming will have a very relevant role to play, not only about telecommunications, but also about censoring. And we were just seeing in the previous presentation, the two previous presentations, two different aspects that can be explored directly. One about the protection and the maintenance of the cables in itself. The other one about usages of the kind of data that those sensors can collect. Of course, we can think about other usage for that data or other types of sensor. But basically, when we think about that, and when we see that we will have all this capacity of data passing through Portugal, but understanding that this capacity is more or less like building a highway where the data is passing. But if I don't build at least a service station in the middle of the highway, the data passes and nothing remains in Portugal. So when you think about this capacity of connectivity, we also must think about how to use it so some of the value that data brings stays within Europe and in Portugal and can be used not only for that purpose of building value in Europe, but all over the world. So basically we have a risk of bypassing the opportunity to build other data processing units, data centers that can put that value being generated inside Portugal and inside this triangle that we can see there between Portugal, Madeira, and Azores. Basically, it's very easy to see that a big piece of for instance, the maritime traffic passes through our economical zone, that in the near future, 20% of the submarine cable capacity will cross the same zone, and these together with all the opportunities in terms of connectivity that we are seeing arising, namely what I told you before about UK and the capacity that we have to reinstall there, or the new position of Portugal connecting Europe to South America, to Africa. And just there we see a huge amount of opportunities to create new businesses, value, and new ways of exploring that data. Basically, when we talk about digital economy, we talk about digitalizing the world, everything, and the sea as well. And the thing is not very difficult. You just have to build the sensors, position those sensors where we want to collect information, transmit that information, that data, where it can be processed, and create value after the processing of that data. The thing is, to do that efficiently, we have to do it in an integrated network that connects the several layers of these sensors. And we are talking about sensorizing the sea, for instance. So we have to create capacity to sensorize the bottom of the sea, sensorizing cables, putting test beds on the seabed, and other artifacts, technological artifacts to collect data is part of that layer of sensorization. But then we have all the rovers and all the SUVs that you can think of, submarines, etc., that are in mid-deep zones. Then we have the sea surface with platforms, different platforms, ships, other kind of platforms. And we have the aerial zone, and all these sensors collecting data, they should be putting this data somewhere efficiently to be processed in real time, or otherwise in scientific terms, to produce more investigation, innovation, and to bring more value. And I would go to the near space, basically the LEO satellite layer, because these would be the ecosystems that has to be connected efficiently in the same network. We have seen developments in terms of communications and interconnectivity in each one of these vertical layers, and only now we are starting to see networks happening. But this has to be improved a lot, and we have to be much more efficient on this way, so we can collect all this data in a way that we can understand, create knowledge, and start to plan strategically what we want to do with all these this area. Basically, we also have to think that collecting all this data demands infrastructure, telecommunications infrastructure. And the cable that we are thinking on sensorizing to collect data is also the transporter of that data to some data center where it's processed. Also, all the other sensors will have the same connectivity need. And in that sense, the question we have to ask ourselves is if the owners of this infrastructure that have been layered, if the investors that at this point in time are investing in creating new submarine cables or putting down new submarine cables for their operations, with most of them with very own commercial interests, are the ones that can provide us science interests or defend the science interests or even the sovereignty interests. So basically, when we create these metaverses, these digitalized new worlds, the question is, since this new world doesn't follow the geopolitical boundaries, for instance, country borders, to what point these huge infrastructure entities are actually defending and providing the best costs for science, for instance. So will they want to make available their infrastructure to pass scientific data at very low cost or even zero cost? So basically, we have to understand that this kind of investment in connectivity has to be also balanced in terms of what is expect the data to be used for. So if it's for science, for defense, for sovereignty purposes, the question is if a pure commercial lender is the best possible partner to assure these components. So having that in consideration, we have a huge amount of opportunities to digitalize the sea or digitalize the blue. We have the ports, the maritime traffic, the cargo and transport, the geological analysis, biological, all the part of health, pharmaceutical, security, and defense. So all these areas can be the base of value creation based on data, on information that is collected by all these sensors. That's why I like to say that when we talk about blue economy, we have to talk about, and very firmly, very seriously, about blue data, blue science, blue knowledge, blue sustainability, and finally, blue sovereignty. And never, as in the probably 40 years before now, we have been discussing this sovereignty thing so deeply as we are now, for the reasons we all know. Basically, so of course, all this infrastructure has to be supported by skills, by governmental strategies, and again, if we are having a EU digital decade, if we are having a digital compass, and if we are having a certain number of initiatives, like for instance, just right now, the government, the Portuguese government, launched a new initiative, which is the Smart Cities strategy. The question is if we do, in fact, have a strategy, a connected network strategy to connect all these components that we were talking about just right now. So basically, we have to ask, when we digitalize the sea, capturing all this data and processing all this data, to whom are we processing this data for? For instance, there is a very interesting project that was brought to me recently from Microsoft about this huge computational system, data center, that is collecting data, actually environmental data from all over the world, from the sea, land, about everything, fires, hazards, conditions, and they are collecting that for free and showing then, allowing science institutions to access that data for investigation and innovation purposes. Even so, I don't know if when we connect this with sovereignty and defense, that would be the best way to process that data. And I'm not sure about what the best way to connect these tools. But we have to ask this question: where is being processed this data? Who is getting value from it? And how can we address a strategy that makes sure that we retain that value to increase our capacity in the future, also to manage, to plan, to manage, and to explore this huge resource that is the sea. Sometimes when I think about the metaverse, thinking that, for instance, a small country like Portugal doesn't have any chance of competing, creating new universes like Facebook is doing with Meta, or Microsoft is doing with Mesh. So the thing is, if we don't have any chance to create a new metaverse that would compare with these ones, where could we have a chance? And I think, really, in this area of digitalizing the sea, we would have that capacity. There, we could have a chance of creating a new metaverse, one dedicated to the sea. We have all the conditions to do that. Geographically, strategically, with the knowledge base that we have, with our universities, the knowledge capacity that our universities are producing, we could do that. We could create maybe the Atlantida, which should be a new sea metaverse. A metaverse where we could explore digitally all these data, all this knowledge, and all these opportunities. Of course, all these investments have to be done with a purpose. I would say a blue purpose, and I would dare us to think how to connect better the vertical strategies from the industry, from the academy, from governments, from our population, creating a new digital capacity in Portugal that would explore this triangle, or this prisma. Actually, is a triangle prisma connecting the bottom of the sea to the first layer of satellites. We could, in the future, talk about other things, but to assure all those blues that we were talking before. So basically, this is my presentation, and I think now we will have a Q&A moment. Thank you so much.
Thank you very much. I was informed that don't go away, please. I was informed that the presentation by Mariana Batista and Rashid Omira cannot be done because we couldn't get in contact in a good way. So I ask you to sit here for the discussion, please. And Vitor Silva, if you can come. The other speaker is not here anymore, so. Okay, so now we have some minutes for discussion. So please, questions from the audience. No questions from the audience? Oh, yeah, please.
Just a simple question. Let's be optimistic and consider that in 2025 will be available the data necessary to implement the early warnings for earthquakes and tsunamis. Then that means that this could happen in 2 or 3 years. The question is simply, what could you do from now on in order to implement such a type of mitigation concerning the preparation of schools, buildings of high density, of public bridge distribution of energy, of gas, railways, highways? What can you do from now on? If not, you can have a suspended time to initiate some results from the data that you have from the information that you could have from the smart cable.
Maybe I can, I think, the question probably needs at least like 5 different people to answer that question, because I think it goes to very different fields and different institutions. I can tell you just a little bit about my experience on the early warning system side. I've actually been in a few earthquakes in California, in Mexico, and in Indonesia. And in the earthquake in Mexico was actually quite interesting because they do have an early warning system. And I was in my hotel, I think on the maybe 5th story or 6th story or something like that. I start hearing the alert, which was the sirens going over the city, and I did nothing. And I was in Mexico to talk with the Mexican people about earthquake risk. So I was a very bad example. I was a very example because I never had the earthquake drills. I never had the education in school. So I was not programmed to react to such an alert. The Mexican people is a completely different story. They were very professional, very organized. They knew exactly what they had to do. They went to the roads. The people that were driving their car, they just stopped their car. People were just talking normally on the street because they have been trained and they know that every time they hear this alert, they have to do this. So I think there was minimum disruption in Mexico when this happened. In Italy and also now in Portugal on the schools, despite the fact that I'm from Aveiro and the seismic hazard is not very high in Aveiro, my nephew and my niece, they have drills where people, basically professor explained to them what is an earthquake, you should go under the table or you should take different measures to do something like this. So when we're talking about the fact that adding this smart component on the cables, maybe it's only another 10% of the cost of the cables. I don't think it's just 10%. It is 10% on the cable itself, but then there's this huge investment in the community to basically train the people, make sure that IPMA has also the necessary equipment to run such a system. But I think we have to start somewhere. Right. And I think, for example, the fact that this is already taught on our schools with the students, it's already a beginning. I want to say beginning. And I think basically if such a system were to exist in Portugal by 2025, I think we just need to make sure that, for example, the civil protection, the schools, the education system are also ready to digest such a system. At least that's my opinion and my experience in these places where this system is already implemented.
More questions? I have a question for Vitor Silva. In your calculations of the benefits, I didn't quite follow what you consider as the probability of an earthquake. Was it once during the lifetime of the system, more or less?
Yes, that's a very good question. So basically, I used a probabilistic seismic hazard model that was actually developed by Instituto Superior Técnico here in Lisbon. And this model basically takes into account all the possible earthquakes that can happen in Portugal. So they have very different seismic zonations in different parts of the territory, offland and inland. And for all the possible earthquakes, so let's say magnitude 8, 9, 7, 5, they have basically an annual probability of that event happening. So for example, maybe a magnitude 8 can happen once every 1,000 years or 10,000 years. So when I'm considering, for example, the impact of a magnitude, let's say 8, maybe it's going to save Portugal 10 billion euros. but that 10 billion euros is multiplied by the probability, the annual probability of occurrence of that event, because I want to make sure that, yes, the benefits are fantastic, but this event, it's only going to happen maybe once every 10,000 years. So I take into account these probabilities of occurrence of the events. And then I do multiply by 25, because basically I take into account that if the system is going to work for 25 years, then let's say, I almost shouldn't say this, but I will say, we have more time for the earthquake to happen because it's 25 years as opposed to 1 year.
I would like to complement having this idea in mind, which is brought from the presentation I was having before. This data, I mean, we are calculating. This calculation is made on the base of the probability of event of this type in itself. And the numbers that we are crunching there are directly related with this event particularly, but that data can be explored scientifically in many different ways. That data is having a different set of value that can be explored as well. So it's not like we have those sensors lying dead on the bed, the bed floor of the ocean just for this purpose. This is one of the ultimate purposes, but we have a lot of other usage for that data. Correlating with other data, it can bring a lot of value and depend a lot on the type of sensors, like 10% overhead or 15, depend a lot on the type of sensors that you put there. And if you connect it with slightly different kind of sensors, then there are many other areas that can be using that data, and the cost is the same. So I can also sometimes I ask, how much does Portugal gain just from installing, being one of the first countries in the world installing this capacity? What kind of revenue comes from there? In many terms, I would not say national marketing, but as well. There are a lot of other value estimations that can be added to this one that relates only to this kind of events in itself. About the question, what do we have to do to prepare in that investment that was referred, this would allow us to introduce in our civil protection system an automation process that we don't have yet. And it's peanuts in terms of costs when compared with the efficiency, the gain of efficiency of the system. So the data produced by these sensors processed in some data center that would allow automatic response to electricity, to gas, etc., with automatic triggers can bring huge value for different purposes as well, but basically in terms of response efficiency. That has to be done yet. We have a couple of years, but that has to be, actually that system has to be produced either way, I would say, because this kind of event is not the only thing that will disrupt globally infrastructure in Portugal. Other kind of events, even cyber attacks, can do it very easily these days. So the result would not be different, interrupting the flow of energy or gas or whatever. The automatic system would be basically the same.
Sorry, my question is not exactly what it's necessary to do. I have an idea of that, obviously. But how are you going to implement that? Where is the budget for that? It takes time. It has a significant cost, probably much higher than the smart cable.
Well, since we are talking about resiliency of networks, both electrical or gas or any other basic mean providing network, I would say that those kind of investments are always having three parts. At this point, a part of it comes from EU funds, another part has to come from the government, and the third part from the private companies or the companies that are actually actuating those networks. It's also their responsibility to assure, also by law in several cases like the critical infrastructures, to assure the resilience of those networks. So it will have to be a combined investment base.
Thank you. We have here a question from one of our attendees that are from attending by Zoom. It's Thomas Cooper. We learn how important this infrastructure is for connectivity and measuring, but it seems very vulnerable. How can we protect it, particularly as we have learned in February that not everybody in Europe has good intentions?
Well, the $1 million question. I'm glad we start with the easy ones. First, let's start, for instance, with the cable system, the submarine cable system. Well, we have noticed, for instance, a couple of months ago, more than a couple, but anyway, several months ago, we have noticed that the Russians were in the North Sea were trying out these new submarine launch drones according to them, to be able to repair cables. Well, repairing cables sometimes means the capacity to cut them and to put them together again. So what cuts a cable to repair it also cuts it for any other purpose. But the thing is, that's one opportunity that I have actually kind of brought there, which is there is a new opportunity to protect, to secure these cables. And this would mean that we would have vessels and drone capacity like we saw in the 2 presentations ago, to have these cables under vigilance and with means that would allow us to rapidly answer to a breach of security event considering these cables. This is very important, and for this overall strategy, data strategy in Europe, this is determinant because the North Sea gateway at this point is being studied as for security, and the results are not famous. That brings us actually some strategical advantage down here in Portugal to reconduct that capacity, also because we have, due to our huge economical zone, and especially the Atlantic platform zone, the continental platform, we are one of the few countries in the world that is having the capacity to protect almost half of the Atlantic. And this is something that we should be aware of, both for defense and to provide services to assure security in these cables to those that want to implement that infrastructure in this part of the Atlantic. About cyber security, well, there is a lot to be done. We have seen that very recently, also in Portugal. But for instance, again, in the North Sea, in Finland and in Norway, they are having this gateway, especially with the United States, where 60% of the Russian traffic passes. And, well, we have to be more concerned, I would say, and aware of the cybersecurity protection mechanism that we implemented there and here. That also goes for the data. That's why I was saying it's not only about collecting data from all these sensors. It's where is this data being processed and how do we protect that data? Because this data, like the person that just posted the question says, can be used for nice purposes or not so nice for not so nice purposes. So we have to build up that cyber security infrastructure and capacity, which connects with what we were saying about resilience of the networks. The communication network is also one of the critical infrastructures in Portugal that has been protected, has to be protected together with the other infrastructures. Just right now, we are having an event of earthquakes, small earthquakes, but hundreds of them in Açores as we speak. It started to happen 2 days ago, I think. So it's a continuous event of earth shakes or earthquakes. And we are concerned about if the submarine cable is disrupted, for instance, for energy at the CLS, how can we cope with that? So we have to, if we augment the need for this infrastructure, we have also to augment proportionally the need to secure it.
I would say that this is exactly the point. It's necessary to take all this into account. We have not many time to do that, 2-3 years, to take advantage of the smart cable. And in any case, it's necessary to plan, to create procedures, regulations, and to issue regulations, regulatory principles, to modify some already forcing structures to take in account with a lower cost any type of mitigation. And it's necessary to initiate this type of activities. And it's necessary to define who is doing that.
One of the main problems, I would say, is actually the number of participants in all these processes and managing strategically this huge number of participants, of responsibles in several areas. Even in regulation terms, we are not where we should be, in my opinion. This is a personal opinion. We have a lot to do to converge the different vertical regulation frameworks to provide an overall framework that would assure from the scratch, so from the first moment, aspects like security or how to handle the data that is produced by these systems, or actually who accesses it and how it's accessed. So we are agreeing on that.
Since you mentioned the project of compiling the let's say the submerged universe of the oceans, and the fact I'm a nautical archaeologist, and the fact that any shipwreck provides a very high time resolution context and is affected by any time-related process like sedimentation, which means for non-archaeologists like you people, they are absolutely marvelous sensors. And I wonder when those sensors will be part of the panoply of the working tool, because they are working there. And I just will mention an example, which is very well known in my field, of Louisiana, an oil company running some kind of a pipeline. The imagery, side scan imagery runs, you see the pipeline running right on top of the 18th century shipwreck, which means that in the planning of the operation, there was side scanning, there should have been magnetic radiometry. I won't touch that question, but simply side scanning. So there was no step to allow for the visualization of the data and the deviation by 10 meters, and then using the shipwreck as a very high resolution sensor for any future investigation regarding the natural process on that site. So my question is, are you aware in your international contact of any country which is, I'm asking the question, knowing half of the answer, but I'm still hoping that one day it will start, because any operation like those installation of cables are the unique opportunity to cross the data. And so the problem is that those sites belong to humanity, and sapiens will destroy them. But maybe it's a good idea to use them before being destroyed. So it's a question and half an answer. Sorry.
Well, I'm not for sure the right person to fully answer your question, but I understand your question and I can have a comment or two about it. One is actually in Portugal, we have a framework that is integrated in the regulatory framework that assures that that data is provided to the state entity that actually licenses that area of the global licensing of a landing cable. So there is someone that has actually to perform that analysis and to provide that data for governmental usage, at least. But we come again to the first question about how do we collect this data, who owns this data, and where should this data be supported at? Because what you are saying is absolutely true. I mean, what happens is most of these studies, they are not conducted, the bigger ones, they are usually conducted by private interests. So basically it's to say that the data belongs to the private company that collects that data, since they did the investment to collect it. And what kind of data reach the government about that data collection event, we don't know. Again, if this would not be entirely done by pure commercial private interests, maybe the thing would be different. Or creating regulations that would oblige them to put all that data in a common data center that can be then used, accessed for every kind of correlation studies, innovation processes, academy, etc. So definitely you are right that data should be open data for several purposes, but I don't think, like I say, I'm not the right person to answer you. Actually, what we are trying to do is we have to balance that need to protect our patrimony with the need to support investment. And what I can tell you is that we are trying to build a one-stop shop process for landing cables in Portugal that would have a slightly different perspective, which be the pre-evaluated landing and pass-through sites. So basically, instead of asking where is exactly you are going to put your cable, and then we go there and we investigate all the cable landing areas to see if patrimony would be there that would have to be protected. We would say that we would analyze a broader range of passage and say, we know that here we don't have anything, a kind of greenway. Here we don't have anything. So if you land your cables here, you can have an immediate license, and we don't need to go there and evaluate case per case if there is something there, because that was already done once. So basically, it's either you put your cable here and it's very fast and you don't have to pay that survey, or you choose other way and that will have to be done. But what countries, I don't know exactly, to be frank.
I think, please.
Okay, just real quick, really a comment. I admire your vision and ambition for a C-verse, Portugal-verse, and so on. Just a minor point. Often people talk about connectivity and sensors and everything, and they ignore, especially in the deep ocean, the need for power. That everything in the deep ocean depends on power. So that has to be part of the solution. So just a technical point, really. Thank you.
I think there is one more question, and then we have to close our session.
Yes, we have just one more question from Thomas Cooper. In Norway, a 5-kilometer piece of cable disappeared. The weight was something like 10 tons. It was a smart cable used by scientists, but based next to a Norwegian submarine base. The Norwegian Navy scanned the data and removed confidential information first. It seems a third party took the cable. Any thoughts on this? I do not really have a question.
Well, I also don't really have an answer.
Yeah, last question. Oh, answers.
First, it is a very good question, but just a correction. That was not a smart cable. It was not a telecom cable. It was a cable for observation. It seems rather strange because this cable was laid in the coast of Norwegian. Then it disappeared. Can the motive can be several, like a landslide, the turbidity currents could take away the cable far away, but 10 tons of cable is too much cable, and it seems to be very strange. But this was not a telecom cable. Even so, in a situation of war, the first step is to cut the communications to the enemy, and the submarine cable is essential for any interconnection. Thank you.
So I think we are coming to the end, and I would like to thank all the speakers and all the discussion. I think it was a very, very interesting discussion in first part, but especially in second part, with very hot topics. And I had one or two questions that I did not put them to create more entropy. But I think it was a great opportunity for us to understand a little more what is the situation with the CAM launching of the submarine cables and the smart cables. And I think the audience got a lot more information and understanding what is this all about and how much we can gain. There are a lot of benefits. Vitor Silva told us the most obvious ones. There are more because we have problems in cascades, like you mentioned, and they are probably even more costly than the direct damage from tsunami and from earthquakes. But also these smart cables do not give us information on earthquakes, give us information on temperature. So this is connected with the global climate, give us information on, I don't know if other sensors can be in the future, like measuring the salinity and things of that kind that you mentioned. I don't know if we stop with temperature, pressure, and acceleration, or if there is some idea to include something else. But anyway, the information that comes from the smart cables is really incredible. And I think we are opening a new world, because when data will start filling up all our terabytes of stores, will be having the need to get better algorithms. We need here artificial intelligence and whatever to be able to look at the data in an easy way, because it will be impossible by ourselves to do that work. So we have to move into new worlds and new situations. So I'm very pleased with what we learned here. And so I pass the word now to you to finish this interesting session. Thank you very much.
Thank you. Well, just a wish. And I think that's the best way to end what we had here today. Is that we are capable of more integrated approach, more collaboration, to actively have all these verticals that we were talking about: defense, sovereignty, academy, investments, strategy, much more aligned, because we are seeing there are several strategies for each one of these verticals. But every time I look at it, I see it still very dispersed. So it's like we have a couple of conferences along the year. There are aligned objectives, both from Europe, from Portugal in this case, and other geographies. But I think there is a lot to progress yet in terms of collaboration platforms that are much easier these days. I mean, today we can have very easily frequent meetings with people from all over the world over Teams or Zoom or whatever, which are much more efficient than they were many years ago. So I think that my wish would be that we would work really together and in a continuous way to align investments, founding opportunities, the academy work, to have innovation oriented to this purpose of the blue economy, and this triangle that we have seen here, the continent Açores Madeira triangle, with more nomad people coming to Açores and to Madeira, with data centers processing oceanic data in the continent, in Açores and Madeira, and actually to produce this new ocean metaverse that we have to name yet, but I hope someday we will be there. And of course, ANACOM is available to all of you to support, interconnect, to integrate your thoughts, your actions, and to provide our help and our knowledge to whom would want to continue discussing this and more likely actually to have actions and something going on about development. So thank you so much. I thank the Academy. Like I said, it's a huge pleasure to be discussing this in the Science Academy, the proper place to discuss it. And I will be available, we will be available for you all whenever you want to contact us to do stuff in this area. Thank you.